Hello friends, very good evening and welcome to CEC live lectures. In the previous few lectures in the series, we have discussed certain important classes of plant secondary metabolites like alkaloids, flavonoids, terpenoids, volatile oils and tannins. So in continuation with the series, today I am going to start with yet another important class of secondary metabolites, that is resins. Now before I move on to the main presentation, I'll start this with a quote from a poem, The Gum Gatherer, written by an American poet, Robert Frost. And an extract of this poem says that what this man brought in a cotton sack was gum, the gum of the mountain spruce. He showed me lumps of the scented stuff like uncut jewels, dull and rough. It comes to market golden brown. So this is just an instance or an example where even poets have mentioned the resins or the plant exudates in their poetry. Now coming back to the presentation, in this lecture we are going to learn about that what plant resins are and are not. And why I have given this caption, because in yesteryears when there were no sophisticated analytical techniques, there was a lot of confusion about the plant exudates, and majority of the exudates were considered as either as resins or as gums, because there were no means to identify the chemical constituents or the chemical composition of those exudates. Then we will discuss about the distribution of resins in the plant kingdom, how these resins are produced, what are the various plant organs that secrete these resins, how these resins are produced inside the plant, and how these resins reach to the secretory organs in the plant. Then we will discuss about the properties of the resins, both physical as well as chemical properties, what is their basic composition, what is their solubility profile, what is their physical appearance or physical nature, and so on and so forth. Then we will discuss about the composition of the resins, what are the basic constituent or the type of chemicals that are present in the resins. After that we will go on to the classification of the resins, how these resins are classified, whether on the basis of their formation or the production in the plant, or on the basis of their occurrence, that how they occur in nature or in their combination, in various combinations when they occur in nature. So they form the basis of their classification, and in the end we are going to discuss different uses of these resins, whether they are industrial uses or traditional uses or their medicinal uses. So as I told you that earlier there was a lot of confusion regarding the true identity of these plant exudates, which we call them as resins, and this was rightly pointed out by Josh Etel, and he stated that the literature on resins, although relatively abundant, is not very precise as far as the exact use of term is concerned, that is, the term resin is concerned. Confusion which in a way reflects the complexity of the word of resins. As I told you that there were no such sophisticated analytical equipments at that time which were used to differentiate, which can be used to differentiate between the different plant exudates. Now we know that there are different plant exudates such as resins or gums or mucilages or latex. So there was no mean to differentiate chemically these exudates, though the differentiation was made slightly on the basis of their physical appearance. Now as we discussed, the resins were considered as sticky plant sap or oxidates irrespective of their chemical composition. So whatever the plant oxidates were available, or if any oxidate is there on a plant, it was considered as a resin, and largely it was considered as a sticky sap. Whether it is a gum or a resin, it hardly there was any difference that was made during the yesteryears. But in 1940s and 50s, when the chromatographic techniques or spectroscopic techniques were developed and identified, they basically provide the mean of differentiating these plant exudates, different classes of exudates. By using chromatographic techniques, various scientists, they come to know about the exact chemical composition of resins, how these resins were differentiated or can be differentiated from the gums or mucilages. As we know that gums and mucilages are more or less carbohydrate in nature rather than the resins, which we are going to discuss in subsequent slides. And vis-a-vis spectroscopic techniques also help in identifying those chemical constituents that were present in the resins. And not only these chromatographic or spectroscopic techniques, but the advent of electron microscopy also helps in improving the understanding about these plant exudates, that is resins. And after discovery of electron microscopy, the scientists came to know that how these resins are formed inside the plant and how these resins are transported to the secretory organs. What are the different kinds of secretory organs that are present in the plant, which basically secrete these commercially important secondary metabolites. So this is how basically the understanding about the resins, I will say, improved over the period of time. So today plant resins are defined primarily as a plant exudate, which is a lipid soluble mixture of volatile and non-volatile terpenoid and or phenolic secondary compounds. So since now we have a lot of chromatographic as well as spectroscopic techniques, so therefore the definition of resins has been more specific and comprehensive. Earlier they were just considered as the plant exudates, but now we know that they are mixture of volatile and non-volatile terpenoid or phenolic compounds. And these compounds are usually secreted in specialized structures located either internally or on the surface of the plant and or potential significance in ecological interactions. So again, with the advent of electron microscopy, we came to know about those specialized structures that can be either present internally or on the surface of the plant, which causes the secretion of these resins. And vis-a-vis, these resins were found to have a potential significance in developing the ecological diversity as well as interactions between the living systems. But if we go on to the simpler definition of the resins, if we want to simplify the previous definition, so we can state that resins are the amorphous solid or semi-solid substances which are complex chemical entities. Mind you that these are the complex chemical entities, not the single chemical entity like we discussed in case of alkaloids or flavonoids, but these are the complex entities that are invariably water insoluble but mostly soluble in alcohol and other organic solvents. And we can also define resins as the complex amorphous product of more or less solid characteristics which on heating first get softened and then melt. That is, this indicates, now these definition basically also indicates or cover up their properties, whether it is a physical property or their chemical property, because in the second definition you can see that it indicates the fusible nature of resins, that is, they get softened first and then they melt, whereas in the definition above we find the solubility profile of these resins. Now we move on to the distribution of resins. So as the other secondary metabolites, resins also have a wide distribution amongst the plant kingdom, and specifically in case of spermatophyta, that is the seed bearing plants. And majority of the resin bearing or the resin producing plants, they belong to either angiosperms, which we call them as enclosed seed plants, as well as gymnosperms, which we call them as naked seed plants. Very few examples you will find of the plants that produce resin in Pteridophyta phylum, and most of the resin producing plants in Pteridophyta belong to the ferns category and their related species or their allies. But the resin producing species have not been reported in Thallophyta or seaweeds or in the fungi. Now when we talk about the distribution of resins within the plant, then as I told you that there are specialized structures present in the resin producing plants that basically store the resin or secrete the resin. And if we broadly categorize, these are three major types of specialized structures. One is resin cells, or sometimes also known as resin cyst or pockets, and certain elongated structures of such elongated structures are also known as resin canals or resin ducts. And then we have schizogenous or lysogenous or schizolysogenous cavities, resin cavities that are present in certain types of plants, specifically in case of pine trees. And then we have another secretory organ, that is glandular hairs, which are, or these are also known as glandular trichomes, which we are normally found in cannabis or bhang, which is commonly known as bhang. So you will find these trichomes on the aerial parts of cannabis sativa. Now, apart from these specialized structures, sometimes resins they basically impregnate into the entire tissue where it is mainly present, and the most common example is guacum resin. And if you see the occurrence of resin in the tree, that is Guacum officinale, you will find that the entire resin is spread throughout the heartwood portion, or I will say the xylem portion of the stem. So this is another example where resin is not present in the specialized structures, but it is spread throughout the entire tissue. Now, apart from that, certain insects also help in developing or producing resins, and they basically suck the plant juice, and that juice gets converted into resin, and this resin ultimately covers the entire insect itself as well as the twig of the plant. And the most common example of this type of resin is shellac, that is obtained by the Lacifera laca belonging to Coccidae family. Now, next is that how these resins are produced. So, as I discussed, that there are certain specialized organs in which these resins are stored, or we can say there are other organs that secrete these secondary metabolites. So, if we broadly classify these specialized organs, we can classify into the endogenous as well as the exogenous secretory organs. Now, how these are produced, before we move on to the exact production, first I will discuss about the secretory organs, that what are the organs that basically secrete these resins. Now, as the name indicates, endogenous organs are those that are present inside the structure or inside the cell. So, these are the secretory structures that are present inside the cell, and they are generally referred as glands or canals or ducts or cysts or laticifers. Now, laticifers is a specialized structure, and it is found only in those plants where resin occur as a part of the latex, or it is produced by the plant along with the latex, and this is largely found in the plants belonging to angiosperm. Now, once the resin is produced inside the cells, it is then transferred to a specialized area which we called it as an intercellular space or the lumen. And in this picture you can see there is a blank space in between which is written as canal lumen, and this lumen is surrounded by the secretory cells. Now, the resin is basically produced inside those secretory cells, and then it is transferred to the central vacant space which we call it as lumen or intracellular space. And whenever the plant is injured, basically the secretory cells or the cells surrounding this lumen, they get degenerated or they get damaged, and immediately resin oozes out from this intercellular space, or what we call it as a lumen. Now we move on to the exogenous organs, and again, as their name indicate, these are the secretory organs that are present on the outer side of the plant, and the most common example of exogenous organ is the glandular trichomes or the glandular hairs. As you can see in this picture, there are different types of glandular hairs. Some are sessile, some are having stalk and a glandular head, and glandular head can be multicellular or unicellular, same as with the stalk of the trichome. Now, in this picture you can see the trichomes of cannabis sativa, which is commonly known as bhang. Now, the trichomes they basically contains this resin in cannabis, and you must have seen certain people who basically use cannabis for their recreational purpose. They will just rub the aerial parts of the cannabis branch or the leaves of the cannabis plant. By rubbing, they are basically rupturing these glandular trichomes, and whenever these glandular trichomes are ruptured, resin is secreted, and once sufficient rubbing has been done on the leaves or the aerial parts of the cannabis sativa, they remove the leaves or the vegetative part, and they use that resin that has been secreted by these trichomes for their recreational purposes. So this is an example of an exogenous organs that secrete resin. Now coming on to the synthesis of the resins. Now, as we discussed that these resins are mainly composed of terpenoidal or the phenolic compounds, and as we know that terpenoids are largely produced by the mevalonic acid pathway, and the phenolic compounds, they are largely produced by the shikimic acid pathway. But the major site of synthesis of these components which constitute the final resins are the plastids and the smooth endoplasmic reticulum. Now, these are the two major sites where basically resins are produced inside the cells, and sometimes in certain cases the synthesis or the production of resin starts in the leucoplast and get completed into the endoplasmic reticulum. Now, I will not go into the detail of those pathways, that shikimic acid pathway or mevalonic acid pathway, which we have discussed in my previous lectures when we covered different classes of secondary metabolites. So terpenoids and phenolic compounds are produced by these two pathways in plastids as well as endoplasmic reticulum. Now, once these resins or the resin components are produced or synthesized in the plastid and endoplasmic reticulum, next step is how these resins they reach to the central lumen or the intercellular space where they are stored and secreted from. Now, once they are synthesized in the cells, then the vesicles that are attached with the endoplasmic reticulum helps in the transportation of the resins to the lumen. So whatever resin is produced, it gets shifted to the vesicles that are attached to the endoplasmic reticulum, and then vesicles move towards the lumen where they get lysed, and their cell wall lysis of the cell wall occurs, and the whole of the resin component is released into the lumen where it is stored for the further secretion whenever the plant is being injured. As you can see in the picture, there are two types of secretory structures. One is the canal or the storage structures. One is canal and other is the pocket or the cyst. Now, if we talk about the major difference between the resin canal or a resin pocket or a cyst or a cell, resin canals are elongated structures and they are highly interconnected within the plant, whereas the resin cells or pocket or resin cyst, they are more or less spherical structures. They are not interconnected and they are more localized in a plant structure or a plant organ. Apart from that, the epithelial cells of a canal are highly active in comparison to that of the pocket or the cyst or the resin cell, and therefore the resin canals produce more resin in comparison to the resin cell or the resin cyst or pocket. So this was all about the synthesis or the organs which produce and how they are transferred to the secretory region or the storage organ. So if we want to summarize it, then components of the resins are continuously compartmentalized, because first they are synthesized somewhere else, and then they are transferred to their final location. First within the plastid and the cystole endoplasmic reticulum during their synthesis, which we have discussed, and then in the ER membrane bound vesicles during their transfer within the storage organs. So with the help of vesicles from the site of synthesis, they move on to their storage organs, which is their final destination, and whenever then any kind of injury is given to the plant, these resins are secreted from those storage structures. Now the question is how these storage structures are formed. Now there are three basic mechanisms by which these intracellular spaces or lumen or cavities are formed. One is schizogeny, other is lysogeny or lysogeny, and third one is schizolysogeny or schizolysogeny. Now schizogeny is nothing but it's a normal physiological process which occurs during the growth of the plant. So as the plant grows, the parenchymatous cells, they start getting separate from each other, and when they separate from each other, they start creating intercellular spaces. So as the plant grows, the cells move away from each other in order to increase the girth of the plant, and by doing this they start producing intercellular spaces, and that creates a lumen, which is a storage cavity. This is the schizogeny, or we can say the normal physiological process which occurs inside a resin producing plant. Second is lysogeny or lysogeny. So as their name indicate, this type of cavity is formed by the lysis of the cell walls. Now this lysis can either occur naturally as a normal function of the growth, or it can occur once the plant is being injured or any kind of infection is inflicted on the plant. Now infection or any kind of injury, this also causes the lysis of the cell walls. So as the cell walls get lysed, again the cells move apart from each other, because whenever you inflict any injury or infection to the plant, as a defense mechanism, plants start secreting certain secondary metabolites for its own production. And in case of resin producing plant, such plants start producing resin from such cavities that are produced after the lysis of the cell. So this is basically lysogeny. Then the third one is schizolysogeny or schizolysogeny. Now this type of basically cavities, these are formed by the combination of the previous two. Schizogeny is normal, that is with the growth of the plant, the parenchymatous cells, they move apart from each other, thereby creating a lumen or intercellular space. But vis-a-vis, if any injury or infliction is given onto the stem, the cells, the cell walls of that particular area, the walls get undergo lysis, the walls get degenerated, and there is an increase in the size of that particular cavity. So such cavities are known as schizolysogenious cavities. So friends, till now what we have discussed is the definition of the resins, how over the period of time the definition of resins have been improved, and more appropriately after the advent of chromatographic and spectroscopic techniques, wherein we understood the chemical composition of the resin, that they are mainly composed of volatile and non-volatile terpenoidal compounds along with the phenolic compounds. Then we discuss about the distribution of these resins, how these resins are distributed within the plant kingdom, and within the plant they are stored in specialized structures such as resin cells or resin canals or ducts, or schizogenous cavity, lysogenous cavities, or schizolysogenous cavity. And then we also discuss about the glandular trichomes. Then we move on to the secretory organs, wherein we discussed various exogenous and endogenous organs, how the resins are synthesized, or the site of synthesis of the resin, where they are synthesized, and how they are transported to the storage areas, that is the lumen or the canal or the intercellular space, that are created either by schizogeny, lysogeny, or schizolysogeny. So friends, in the next lecture we will discuss about the properties of the resin vis-a-vis their composition and classification. Thank you.